All right, so that gives us the basis for Hess's law. And so in a careful restatement, Hess's law just says that we can find the enthalpy of a new reaction that we have not tested in the laboratory using the enthalpy rules above to accomplish this, okay, from reactions that we do know and have measured carefully the enthalpy. For example, if we are to calculate the heat of formation of sulfur dioxide gas given the enthalpy of formation of sulfur trioxide gas is negative 395.2 kilojoules per mole, and an additional equation that we can use Hess's law to help us find this unknown quantity. Okay, so there's the given equation. Now we've got to define the heat of formation of sulfur trioxide. So from the constituent elements sulfur and oxygen, we form sulfur trioxide gas. Okay, now we're not balanced, so we have to balance this with 2, 3, and 2. Okay, and at this point we say, well, this is not the heat of formation of sulfur trioxide. 1 mole formed is the heat of formation, so we actually have to divide the equation that we are given by 2. And so when we do that, we use one of our properties that we had, and we get sulfur, one of them, 3/2 of oxygen gas, and we get 1 sulfur trioxide. And this delta H of formation we just said is 395, negative 395.2 kilojoules per mole. Okay, so looking at this, to get heat of formation, we want SO2 on the right hand side of the equation. So we're going to flip this equation to its reverse. And when we do that, we get 2SO2 plus O2, and on the left hand side 2SO3. Now, delta H of this reaction is going to be now positive 198.2 because of our flipping of the reaction. We have to multiply by -1. So now we want to cancel out like terms, and specifically we want to cancel these guys out. Well, we can't do that as of now because we don't have equal numbers of SO3. We have 2 versus 1. So we need to multiply the top equation by 1 or the bottom equation by 1/2. Either one works. Okay, or multiply the top equation by 2 or the bottom by 1/2. So let's go the top by 2. And if we do that, a new equation that I'll write down here, we're going to get 2 times sulfur plus 2 times 3/2 is 3 times oxygen is going to give us, and now this is out, so we're going to ignore that again. Okay, it's going to give us 2SO3, and that delta H of the new reaction is going to be twice that of the old, so negative 395.2 times 2 is negative 790.4. Okay, so now let's add these together. And again, we're now ignoring the previous because we're no longer using it after that last multiplication. So we can cancel out like terms. SO3 goes away, and looks to me like one of the oxygens is going to go away as well. Okay, so we end up with a new equation, 2 times sulfur, 2 oxygens left over, give us 2 sulfur dioxides, which is pretty close to what we're looking for. The new delta H of reaction that we have is going to be the sum of these two, so negative 790.4 plus 198.2 gives us negative 592.2 kilojoules per mole. But we're not quite in terms of heat of formation. Okay, we've got to divide this equation by 1/2 to get this into terms of 1 mole. And so when we do that, our final equation is going to be sulfur plus 1 oxygen molecule, elements in their natural state, 1 mole of SO2 gas, with a delta H of formation of negative 296.1 kilojoules per mole. And if we check our enthalpy tables, we see that that is correct.